Just giving a marker for Lauren. All right, so this week we're working with reading in files, and we're also going to do try and accept statements. Try and accept statements let you do error checking so that your computer does not blow up if somebody puts in the wrong information. So if you're working with like data input, and you can do this, we usually do it with files to see if the files are valid. So if we're checking to see if the file is there, we can do a try, and we do whatever code is there. And then if we get an exception, we can handle it. So we might get something like the file's not found. And then we can tell the user your file wasn't found, enter in a new name for it or whatever. We can handle it in some way and have the computer not blow up on us. And we've been working our way around this by using while statements up to this point, where we're checking to see or doing things like, is it a capital A or a lowercase a? So this is my least favorite chapter. I find the try and accept statements slightly clunky, but it's important, and it really makes you a much better programmer if you can anticipate problems that your end users might have and handle them. And I like to tell people that you want to be user-friendly and that you are trying to make your program fool-resistant. You can't make it foolproof. There are some really determined fools out there. But if you think of it like being rain or water resistant versus waterproof, if you're water resistant and you're a watch and you're water resistant, you can get it splashed. If it's waterproof, you can go swimming in it. We're just trying to get to we can handle common errors. There are still going to be people who are going to do something so wrong you didn't anticipate it and it's going to break because this is your first programming class. Ultimately, you will typically have somebody who is testing things. If you're working for a company, they should be testing things and have people trying to break them so that you don't have it happening when it gets out to the final end user. So you might release a beta version and have people volunteering to test. I think my favorite story on that one was there was a video game for Star Trek, and if you would pet the tribble, it kept growing larger till it was larger than the entire ship. So you need to test things to catch errors, so that's why beta tests exist. I wish I'd gotten to play that beta test or somebody had gotten it on video, but it's really important to be able to do things, and especially with file input and file output, because you don't always know that the file is going to be there. So we're going to do things like we're going to check and see if the file's there, and if it doesn't exist, we can create it. So there's lots of ways to handle it. We can handle it behind the scenes without going out to the user and causing them problems. Okay? So that's the whole chapter is on using files, using loops to process files, and then exceptions. Next slide. So when everything we've been doing so far is only working with active memory. And we don't typically work with things in the real world unless we have some way to save or store them. Sometimes we save files locally. Normally, if you're working on a phone or something like that, you're typically saving possibly locally, possibly out to something like Facebook where you have a back-end database or something like that, but you need permanent data storage to be a meaningful programmer. So what we're going to do is we're going to save it, we're going to write to a file. Sort of like Word document being saved to a file or anything like that. And there's different types of files that we can work with. We're going to work with two. Usually you're going to work with text files, but you could also work potentially with image files or sound files or anything like that. So we can we should be able to create a file, save to a file, modify a file, which is really just reading in the information, completely overriding it, or deleting a file. Next. Oh, yeah. So we're actually looking, I love that, and you can't really see what I'm seeing, but it's representing a file on the disk, and disks are sort of going away. But you are writing data to a file. You are actually creating an output file. And it used to be, when we were doing input and output in older programs, you'd actually have to specify exactly how long something was going to be. Here they're just stored sequentially, typically in the files, even though we're using a random access format. You'll typically think of like an Excel file or a Word document, which is really what our files are going to look like, and it's going to be one line after the other. So if we're reading data from a file, we typically open the file, read the data in, and we're usually going to store it to a variable. And so the next chapter, we're going to learn how to use lists and other types of things, so we can take an entire file, store it into a list to make it easier to process. Everything that we're working towards here is we're towards the end of the for midterms and moving on from this, what we're going to get to is doing a CRUD program, which is create, read, update, and delete. And this is going to be what you're going to do for a midterm project, and it's just going to be a simple one of your own where you get information from the user who you should be able to read it, update it, and you're going to have a sample program that's pretty close. So you'll have something to work from. It may end up a little bit after midterm. Then for your final project, you're going to need to do something like this in a GUI format, and that's GUI, not GOOEY. So that's graphical user interface, not your kids got jelly donuts all over your keyboard. So in programming, we want to be able to create that external file, and that allows you to save your data. So if you shut off the computer and reopen it, it's still there, because right now everything that we're doing is in active memory, so we're actually putting it into permanent storage. So we have to be able to create the file, we have to be able to read data from the file, we need to be able to update data on the file, which is really wiping everything and resaving it, and we need to be able to delete the file. When we're working with reading a file, the first things you have to do, and I used to do this exercise where I had people do flow charting on how to make a peanut butter sandwich. And people would often say, get the peanut butter, get a knife, get out the bread, take the bread, spread the peanut, use the knife to spread the peanut butter on the bread, and I would stop them because they forgot something. What did they forget?
Joe.
Well, yeah, but what else did they forget? To take the lid off. You have to open.
No, that.
Okay, so, but that's really important because it's the same thing here. If we're going to use a file, but the thing is that we know what we're doing, so, and that's why I have to have people test when I do step-by-step directions, because, and we all do it. If it's something you know really well, you're just like, everybody knows how to make a peanut butter sandwich. You don't think about saying, but you have to open the jar. But when you're working with a computer, you have to get to that level of directions. So before we use a file, we have to open the file. We have to tell the computer which file we're going to open it. And we also have to tell it how we're going to open it. Now, with peanut butter, really, you're only going to use peanut butter in one way. You're not going to be putting stuff back into the jar. But you have options. Hopefully, you're not putting stuff back into the jar. For sanitary reasons, please do not lick the knife and put it back in. But in any case, I digress. So when we're using a file, we have to locate and open the file. And we're basically going to be working with files in the same folder as our programs. So you just need the file name. If we were going to do something different, we'd need the entire path to the file, which we're not going to get into today. So we need to open the file, we need to process the file, and then you need to close the file. And that would be the last step in your peanut butter sandwich, well, would be closing everything and putting it away. Next one. So we can read everything in, and we'll typically store it. We'll take it from the disk, we'll open the file, and we'll read it and store it into a variable. And so we'll copy it from that somewhat permanent storage, permanent just meaning it will last if the computer's turned off, into active memory. Because once it's in active memory, then we can actually do things with the file. Next one. For this class, we're generally using a text file or a binary file. And we can use sequential access, which is what we're typically going to be doing in here, or direct access. So for sequential access, this is a nice one to work with lists, so we can just read it in and step through things one at a time. And this is one of the reasons that I love Python. I really love Python and how it handles lists, because you can do a for loop and step through that list, load it in from a file, load it out to a file. It's great. So sequential access is what we're typically going to use, but you could use direct access where you can go directly to a specific spot in the file. Next one. So file names are important. We need to indicate with the extension, like you would know that if you used a .doc, that's a Word document. So the extension is the type, and we're typically going to be working with, I think it's a text file. I think it's just a TXT. We'll have to look at it, but I'm pretty sure it is. So your file object is your object that's associated with a specific file. So you can reference it by a variable. That's what we're saying. We're loading it into a variable. That's your file object. Next one. File names, hey, when you're naming these, treat it like you would if you were in anything else. We want to be consistent when we're creating our file names. You want to make sure that you don't use spaces because they get funky when you try to do anything. A space to a computer, at least with an HTML file, is that, and you're not going to want to use a symbol. So when we're doing our file names, because you will be creating your own files at some point, make sure you do it like this, file _ name, no spaces. Be careful with those. When I'm giving you files, they'll be properly named, but at the midterm and the final, you will be creating your own files. So you want to make sure that you don't use spaces in your file name. Next one. So when we're opening a file, it's going to create a file object and associate it with the file. So we're going to create a variable. So we're going to have my file equals. So you can tell here that we're assigning it to something. And then we will do open and the file name and the mode. So let's talk about these options here for a second. So the mode has different options. The mode can be R. This is the safest way to open it. It's read only. You're not going to accidentally write over it. It doesn't let you make changes to the file. So R is read only, and it's actually going to be with a single quote around it. And you can have W, which is a write. Be careful because you could write over the existing file. And you can do A, which is append, so you start writing at the end of the existing data. So typically, you're going to want R or A, but if you want to just load everything in and then rewrite it, you can use W. So the file name is usually going to be put up in quotes, and again, make sure your file name's no spaces. Next one.
A is add at the end.
Pardon me?
A is add at the end.
Yeah, that's an append, so it adds stuff to the end. Next one. Okay, so you're going to need the entire location of the file. Now, we're typically going to be using the file name as our full address because our files will be in the same folder as our programs. If you didn't have it in the same folder, then you would have to go in and put in the entire specific file path for it. We won't get there right now. We'll get there eventually. Next one. So we can also write data to a file. So we're using a method, which is a function that belongs to an object. This is actually moving a little bit ahead of us. Objects are special pieces of grouped code that we're going to get to soon. I don't want to get into it too much right now. The file object's write method is used to write data to the file. So it would be something like this. You'd have your file variable, which we had my file earlier. And it's using that dot notation, my file. And I like to refer to this as sort of like our folder and file structure. So we've got my file dot, and then write, which is a method, which is the same thing as a function. And then we're going to pass it a string of some kind. So we take a string literal and we save it into the file. And that's how we write to it. And then whenever you're done with it, the last thing that you should do is you should do my file dot close. This you don't pass anything to, but you have to have the closing parentheses because it is like calling a function. A method is just a function that belongs to something else. So it's really a function. All functions, to be able to do something, you have to have the parentheses, even if you're sending them nothing. So if it's not closing properly, this is the most common error I see when things aren't working right, is that people do that. Most common error I see in this function. Okay, next one. So let's talk about reading the data from the file. So we're going to do a read method. We read the entire contents of that external file into active memory. And so you can't do it until you open the file. It's like opening the peanut butter jar before you make the peanut butter sandwich. That has to happen first. And contents always come in as the string. So if we were going to work with something that's numerical, so say we had a list of numbers that we wanted to get an average of or something, we would have to convert them to an int or a float. How would we do that? Where else are we doing that? When do we have to convert things now? When we get input from the keyboard. All the input from the keyboard that we've been getting comes in as a string, and we have to convert it. So there are ways that we can break it apart that we're going to get into. We're going to typically, one of the ways we use this is doing a read line method. That's an actual command, read line. And that will read in a line. It takes one line at a time, and that way you can process it. And it includes at the end, so if we were reading in names, we might have like a darker one than this. We might be reading in a name like Mary, but what you'll actually get is Mary/n. I think that's going the wrong way. /n. So that's your new line symbol. So each piece of data that's coming in will come in on a new line. So we would potentially have to take that last symbol off, the new line symbol, and we do that, and this is very exciting. You get to strip in this class. When you remove a new line symbol, it's said to be stripping it. So you can strip. You can do a right strip or a left strip, and we can take that stuff off, and we'll get into that in a bit. You can also, when this happens, it's going to mark the location of the next item to be read from a file. So typically, we're going to use a read line function if we want to process each thing as we're bringing it in. So we would read in a line, we'd convert it to an integer or convert it to a float. We might take off that /n, so strip the trailing characters. So that's why we would use read line to read things in one line at a time instead of reading in the entire file at a time. Next one. So we can concatenate a new line to and stripping it from a string. That's confusing. Okay, so typically we're going to, I'm sorry, I'm reading the PowerPoint for a second before I try to decide how to explain it to you guys. Okay, so this is what I was talking about earlier. So just like if we were going to convert something in, if we wanted to bring it in, so one of the things that we're going to be doing is we're going to be reading in a file of popular names. And we're going to be checking, it'll ask the user, so we're going to use user input as well as reading in from a file. And so we're going to read in boy names, and we're going to read in girl names, and we're going to check if you put a name, is it a popular boy's name, is it a popular girl's name? And to do a comparison, we have to take that /n off. So we're going to use the rstrip method. And we're going to take the /n because whatever the user enters, we have to compare the two. The other thing that we're also going to have to do when we get to that one eventually is convert everything to lower or uppercase on both sides, because you can't be certain that your user is going to type things in with the first capital letter. It may not match. Oh, and by the way, I usually check with my own name. So let's talk about user friendliness here. Last year, and this was cracking me up, instead of saying, so you should respond for the popular names one. So it says enter a name. I type in Mary. And this was the response that I got back. Sad face. So yeah, think about what you're writing. You want to be user-friendly. This is not user-friendly. If I had fragile self-esteem, this could make me cry. No, it really wouldn't. So you want to say Mary is not one of the most popular names. Read what you're doing sometimes, guys. Proofread. But yeah, I got that. And I have to admit, I thought this was so funny that I actually took a screenshot of it and showed it in class, just the results. I didn't say who had done it. I'm just like, this is not user-friendly. I don't even remember who did it. But yeah, be nice. Be nice to your teacher. I may not be popular, but you don't have to rub my face in it. Next one. Okay, so we can append data to an existing file. And this is a really common thing to do. So if you have a list of something, an inventory or something like that, you usually are going to want to be able to continue to add things on at the end of the list. You might also want to be able to sort things. If you were doing that, you'd read it in, you'd alphabetize it, then you'd write it back out and replace it. So the first thing that you're going to do is you need to open the file. And if it doesn't exist, you need to create the file. That's the first thing we're going to check for when we get to our exceptions, and it's something that we have to do. Because the first time you run any program, there typically is not a save file for it. So you don't want to announce to the user that, hey, there's a problem, I don't have the save file. You just want to create it if it doesn't already exist. So if the file exists, we're not going to, so right with the W mode, we will overwrite. So if we're writing, we will overwrite and we will replace an existing file. With the append, we add it onto the end. So we're just going to keep adding onto it. So be careful with what you're doing because it's easy to wipe data accidentally. Next. So when we are, it's like writing to and reading from the keyboard input we've got. Everything comes in as a string, and we need to put it out as a string too. So it's just like when we are displaying things on the screen, we can either convert something to a string using the str command, and then whatever we have in here would be converted to a string. It's got to be 42. What other command converts something to a string indirectly? Going the other way for output. For output, what other command would convert something to a string? I'll give you the first letter. There you go. So we can do format, and we can concatenate a string, and so you must be able to convert it before writing. When reading in, if we're going to do math, we need to use int or float, depending on what we're bringing in, to work with those. Next one. So typically, we're going to be doing a lot of file processing, and this replicates how computers were initially used. Computers were initially used, if you think about it, back in the days where the computers were bigger than this room and your first bug was an actual moth. I've told you guys that story, right? Okay. So what typically happened is you would load in something like payroll information, and it would have each user's name, everything that needed to be printed on a check, and it would go through and process the payroll, and it would write the checks, and it would work from beginning to end, and nobody would interact with it. That's how computer programs originally worked. You started it, you waited for the output, that was it, instead of doing something where we're working with it live. So typically, when we're doing something like that, say you have 150 employees, you don't need to start the program and stop it 150 times. You just start it, have it read in, process everything that's there, and when it gets to the last file, it exits. And the best way to do that, if we're doing something over and over the exact same thing each time, and here's a hint, like if we were going to print 99 bottles of beer on the wall, what programming structure would we use? Very good. We would use a loop. And it's great to look at the boards here. That usually helps you with what I'm looking for. So yeah, loops are how you use to process files, because you're going to typically read something in, and you're going to keep it going, and you use it until you get to the end of file. And at the end of a file for Python, we're going to write a while loop with a while line not equal to null value. So that's not a double quote. That's two single quotes with nothing between it. Because when it gets to the last line in the file, it's going to be an empty line. And so this is not. So you keep going as long as you have more data to read in. So that would be your flag telling you that we are done reading in data. Next one. So this is your flow chart on what you would do. You'd open the file. You'd use read line to read in the first line from the file. If it's not an empty string, you'll process it, whatever you need to do. And then you'll go back and you'll read in the next line. And it's going to check every time it reads in a line to see if it's empty. When it's empty, it's hit the end of the file and it's done. Next one. So we can use the for loop to read lines. And the format for it, and this it usually does list this as line. That's just a variable. It's not magic. You could say whatever you want, but it's for line. That's your variable name. Could be anything. In file object. And this is just the variable name of your file object. And then you would do whatever steps of processing. So typically, you would read in the line. You would strip the new line symbol from it. You'd convert it to an integer or a float. You might calculate something. Or commonly, you would be adding it to a total to figure out the total value in there. But everything you do, and then you would, when you were done with that, it would go up to the next one and read it in and do the processing the same. So it works one time for each line in the file. And I kind of love this about Python. You don't need to, so your for statement is actually acting a little bit like a while statement. Because typically with a for statement, you need to know how big something is or how many times you have to do it. But here, it's doing it till it reaches the end of the file. So it doesn't have to go out, you don't have to go out and get the file length first. It just keeps going till it's done. So it's a for statement, but it's acting a little bit like a while statement. Next one. Okay, so we're getting into some new terminology here. Almost all programming is ultimately going to work with the database backend because that's the most efficient way to work with things. And when you're working with data, we use database terms. So think about, let's say we were working with student information. So everybody in here is in a database at MCC. You had to be to register for class. And so if we were going to have student information, and I don't remember what my student ID is, except that it's really low. It's like 9256, something like that. I'm in the 9,000s somewhere. And I can actually, at one point, I could tell you roughly what year you started here by what student ID numbers are. I think we're in the 30,000s now. I started here in 1989. Yeah, so my student ID number, it never changes over time. Once you're in there permanently. Last name and stuff has changed, but that's my unique identifier. If we're getting into database terminology, really, that would be our key field, because typically, if you're working with a lot of data, anything could potentially repeat. So we could have two people with the same name at MCC, especially if it's a common name like Mary Smith or something like that. So anytime you're working with a bunch of records, you want to be able to uniquely identify one and pull something from it. So you'd use some sort of key field. So in this case, it would be like a student ID. So if we had information and we could have whatever else, phone 555 5555. Whatever. So this whole group of data would be considered to be a record. That's the whole thing. Each individual piece of the data would be a field. And you typically have to write by one field after the other or read in from one field after the other until the record is complete. Might go on the same line. Typically, if we're doing that, traditional way to do this with a CSV file. Anybody? Bueller? Anybody? CSV. Here's a hint. The new line symbol would tell you it's the end of the line, right? If it's a CSV file, it's a comma separated value. Common way to read things in and out. There's other ways we do things now. This is an old way. It's still acceptable with Excel and things like that, but we're going to do things sequentially. If you have a record, whole thing, all of it's going to be stored together, one piece after the other. And that'll make more sense as we get more into data structures. Next one. So this is just talking about, and we talked about the CRUD application. One of the things that we also do, and it doesn't make changes to a file, but you need to be able to search through a file to find specific pieces of data. And that's why something like a key field is important, because it uniquely identifies each record. Next one. Exceptions. Okay, so this is a critical and sometimes clunky thing that we need to do. I don't really, the reason that it's a little clunky for me is because I don't always know what error name something's going to be. So we're going to look for specific errors. We don't have one blanket error. So if we try to read in the file and the file's not there, you have a different error than you would have if somebody puts in bad data. If they're looking for a number and you type out 40, that's a different type of error than trying to get a file not found. And there's a lot of errors, and we have a reference that Stefan's going to put up in there.
I think it's still in Canvas. I have to look still.
We have to look, but we've got a list of the common errors. Though if you can't think about it or can't remember what your error name is, I just cause the error. So I'll test the program by deliberately putting in a file that's not there, or I'll deliberately put in a string when I'm looking for text, because that will tell me what error I'm looking for so I can handle it specifically. So if I'm looking for a file that's not found, I want to be able to come back to the end user and say, hey, your file, and give them the name of their file, wasn't found, and then give them options. Would you like me to create one? Then you can give them options and interact with them so that you can fix the problem. So the error message is your traceback. It gives information regarding the line numbers that caused the exception and a brief description of the errors. That's what you guys have been seeing at the bottom of the compiler when you run it. It gives you a traceback message that tells you it didn't work and here's why. So you might get like a shadow error. There's also, and the shadow error is where you are using a name for a function then using the same name for a variable in it. Next one. So a lot of this you can handle without going as far as to try and accept. You can just use a while statement so that if you ask somebody to enter a number between 1 and 100, the first thing you do and check and see is it actually a number? Then you can check and see if it's in the right range. And if it's not, you just do a while statement and keep asking them until they get it right. There are some things that you can't fix with careful coding. You can't guarantee that the file that they're looking for is going to already exist. You can handle it by creating a new one, but you can't guarantee that it's there. Next one. So this is how we handle it. We try something. It's called a try and accept statement. In other languages, it might be a try and catch. So if you see try and catch, that's the same thing in other languages as a try and accept here. So you do try, and then get input from the user, try to open the file, whatever. You try the things, and then you have a exception handler. Go ahead to the next one, Stefan. So you'd put accept and the accept clause, and then you handle it, or skip it and you deal with it. Deal with it however you want. Send a message to the user. You may have to close the program, but you should do it. Your end user should never see those tracebacks at the bottom saying that there's an error in line that. They should get a custom message from you. I'm sorry, your file has not been found. That's the end. So you give them something user-friendly, not the traceback error messages are for you. You handle it and tell the user what's wrong. Next one. You can often, and they call it throwing an exception. So you might have to have a different one for each. So you might have a corrupt file. The file might not be found. And so this is why you would So you can have it, you can also have, like we have the else at the end, you can just have a general except statement, which would be the last one in your list of specific ones. So that's just catching anything else that went wrong that you couldn't predict. And just then you do something, the file has had a problem and we're closing. So you have to handle it that way. Next. So when there's an exception, there will be an object that's created in memory when an exception is thrown, and it has the default error message. And then you can use that and pass the exception variable to a print function so you can display it on the screen, or you could print it out, or you could save it to the file to show what the default error message is. Next one. The else clause. And it's like our traditional if-else statements. So we can work with the try and except clauses, and it's like your if-else decision structure. And then you have an else on what to do if it doesn't work, if no exceptions were raised. So next one. So it's what happens if you don't find anything. So it's try, except. We also have a finally clause, which will execute whether an exception occurs or not, and to just clean up before exiting. Typically what you're going to do in that, if you've opened a file, one of your cleanup things would be you should close it. So you just want to do anything to make sure that you're not causing further problems. You should never leave your computer program without closing the files that you've opened. Next one. And so if an exception is unhandled, you didn't handle it correctly, they're going to make the program, if you don't handle the exception, you're going to get what we've been getting so far. You're going to get those traceback calls at the bottom of the program. And going forward, we shouldn't get those anymore. You should handle it, even with the generic exception statement where you don't specify what the exception could be. Just say there was a problem with the program and it is closed. You should be handling something. Try and except is going to be used in almost every program going forward. Not in the exercises, but in our actual programs. Next one. And so that's it. So this chapter is all about the reading in the files and then catching exceptions and handling them so that the end user doesn't get the tracebacks. Okay, rest of the time is yours.